house. Now, normally you might expect a model like this to come from an architect. This is a little bit of a different story. This one comes to us courtesy of our homeowner.
Kevin, our company makes three-dimensional printers, and that three-dimensional printer fabricated everything that you see on the table in front of you.
They look good. Why do I want the sole of the shoe, though?
You might not want the shoe, but the guy who designed that shoe first designed it in the computer, and the 3D printer was the only way for him to touch and feel his design.
So you're talking prototypes. You're saying that an engineer who has got something in his head or on a computer screen wants to put it in his hands, and you guys can make it.
Exactly.
And make a working model? I mean, this obviously opens and closes. Is this many pieces assembled or a single piece?
It's printed just like that.
Yeah.
Look at this one. This was printed as one assembly. All the gears were aligned, positioned properly, so that when it comes out of the machine, it can operate just like this.
It comes out of the machine looking like this?
That's right.
That is wild. I gotta check out these machines. Obviously, I know you guys use them for architecture. We saw your house. I'm looking at a downtown office building, maybe something out of Moscow's Red Square.
Yep. Architects all over the world are using this technology now.
Makes sense. I mean, they're powerful, right? Here's the old alternative. 2 dimensions. It gives you a drawing, and effective, they can sort of show you the layout, the proximity, maybe the square footage, but it doesn't answer all of the questions. What are all the dotted lines, for example?
Exactly. If you take that design, you extrude it to the 3rd dimension, you get a lot more detail digitally, then you can answer the question. Those dotted lines were these suspended antique beams that we want in the new family room space.
And here we can see that they're up part of a cathedral ceiling. They could even got some color and texture to them. Does the printer give us the color, or is it just build a model and we have to hand paint all this on?
The printer prints out all that color. Basically anything that's in the computer to start with, the printer can output.
Oh, what an improvement from an associate locked in some basement with a balsa wood and a sharp knife.
Now this is what you get.
And it all starts in the computer.
That's right. So it starts here at the computer, and somebody has their 3-dimensional design complete. You can see here we have our front entryway that's been fully detailed with the tile work, woodwork, all the colors and everything.
Mm-hmm.
We're able to preview that here in our software, and once it's ready to go, we just hit 3D print.
And when you say print, you're being literal because you're talking about a printer.
That's right, a 3-dimensional printer. We take that digital design, we slice it into hundreds of really thin layers and recreate them on top of each other right here in the machine. About 250 of those layers for every vertical inch.
And what is it that you're actually printing? What's this white material?
Yeah, the white material is actually specially engineered material. You can think of it like gypsum powder.
Can I touch it?
Yeah. And that loose powder will solidify into a part when we combine print onto it with our binder material.
So the binder is the equivalent of a printer's ink.
That's right. Because the process takes a few hours, I started one here this morning.
Mm-hmm.
This one's already finished. So here we have several inches of loose powder, inside of which is actually the model of my front addition.
Wow.
Everywhere that the binder touched the powder, it turned into a solid object.
Mm-hmm.
The rest of it's just loose powder. I can clean up the rest of it here with this some compressed air.
Okay. Finished product right there. Look at all of the details, right down to the paint colors on the wall.
That's right. And the last step, all we need to do is seal the surface and really help the colors pop. We just dunk it in a little bit of resin here.
That's remarkable technology.
Coming up next, I'm going to have to cut away some of these clapboards.
And they're covered in lead, right? So we've got the abatement issue.
Exactly. But first, here's a tip. Building a gabled roof requires an understanding of geometry. For example, each gabled end is composed of 2 right triangles. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other 2 sides. This is useful because if we know the length of 2 sides of a right triangle, like the rise and run of a roof, we can figure out the length of the 3rd side, which will be the length of each rafter. We'll be right back after these messages.
Roger's making us lots of room for the addition that's going off the back of the house. We've got an addition off the front of the house that's going right here, so we have to make room for that.
Right, we're going to need to put a foundation in, and we can't do that until we get rid of this ramp. Now, the homeowners don't need it, and they don't want it. The good news is that it was built only a few years ago. We tested it. There's no lead paint, so we just take it away.
That is good news.
Now, we also want to get rid of this front porch because it's not fitting to the house. Again, it was built only a few years ago. No lead paint. And it's pretty rotted, so we're just going to take it off.
So we can dig right into this, right?
Yep.
That's not going to take long.
footing, only about a foot deep.
All right, Tommy, what's next?
All right, we're going to actually excavate right here for the new addition that's going to be right here. So I'm going to have to cut away some of these clapboards. All right. Now I have to remove them from the window over.
And they're covered in lead, right? So we've got the abatement issue.
Exactly. Now I'm looking at the rest of the wall. I got split clapboards here. I got a lot of damage right here and all the way up the wall, and the paint's really bad.
I know where you're going with this.
Well, it only makes sense. By the time we set up to paint and then patch, I think in the long run it's easier for me to strip them off and install new ones.
All right, on board. All right, Norm, I am all suited up because we do not mess around with lead paint anymore.
That's right. No longer do we fool around with it at all. Because in 2010, the EPA set up some new rules. It's assumed that any house built before 1978 has lead paint. Now, our house is nearly 300 years old.
So it's a good chance it's got it, and in fact, we tested it.
That's right, and there's plenty of lead paint here. Now, any contractor working on the house dealing with that lead paint has to be certified. And one person on site has to be here to make sure everything's done properly. On the outside, you have to set up this plastic sheathing a certain distance out from the building, the safety tape that goes around to keep the public out and the workers confined, and signage on the building.
Right.
And the workers have to be properly dressed.
And you know what? You will look marvelous.
So do you.
Hey, talk about workers. Let's go up there. Start ripping those clapboards off. Not getting anything done with you guys flapping.
Guess we know who's certified on this job site. Well, it was definitely the right call to pull off these clapboards. They are in tough shape.
Now, they sure are. A lot of splits in these. They're very loose and a lot of lead paint.
I don't know if they're original, but the boards underneath the sheathing, this definitely looks original.
I think that is the original sheathing of the house.
Okay.
All right, well, you guys crank it down. We're going to start picking up these clapboards so don't drop anything.
All right. Now, Kevin, the siding to the top of the window down appears to be newer. It's not as old as the one that was on the gable. And it also has this building paper behind it. And they didn't do a very good job flashing next to this window. They didn't even caulk it. This paper is all wet. It got wet over time, and it actually made a lot of this paint peel off the casing.
We take the clapboards, we wrap it in plastic, and we seal it with tape to keep it contained. And then we take it and put it in a dumpster with the rest of the debris.
Here's a quiz. Where does the term for a bathroom, the John, come from? A, the inventor's dog. B, King John. C, John Adams. Or D, Queen Elizabeth's godson. Stay tuned for the answer. In 1996, the first flushing toilet in England was invented by Sir John Harrington and installed for his godmother, Queen Elizabeth I.
So Tommy, Roger and his guys have cleared us a nice big area for the addition. Some markings are going down. Is this the outer dimension of the addition?
It's a little bit beyond because we want to overdig so we can work the foundation. The family room's going to be 20 feet out, 19 and a half feet wide. Then it's going to jog back in around the chimney for the pantry and then return to the house.
Okay, excavator's here, so we're going to do some digging.
Right.
What's going down? Slab, crawl space, full basement?
Well, it's actually going to be the height of the existing basement right here. So we're going to go 6'8" from the bottom of this clapboard to the top of the footing.
So it's something between a crawl space and a full basement.
Right. Tall enough for me, but not you.
All right, are we ready to dig?
We sure are.
Tommy, what's going on? We got water. You look dejected.
Yeah, well, you never know when you're excavating for a foundation what you're going to find. There's three things you don't want to find: ledge, peat, or water.
And we've got water.
We've got water. So now we have to deal with it. Well, that's actually the water table. So the water's not going to come up any higher unless we get a lot of rain. So we have to deal with that.
All right, looks like Roger's going to be the guy dealing with it.
Absolutely.
And I was not expecting scaffolding. What's going on over here?
Well, we had to bring in Mark McCullough and his crew because this chimney's going to go. A section of the chimney's going to be cut off. They're going to fix it, weave it back in.
All right, so some demolition first, but we've got water. So let me check it with Roger.
Okay.
Roger, you started off digging a hole and you ended up with a pond. What's the story with this?
Too late for an in-ground pool?
I think it is.
Take a look at this soil, Kevin. You can see right here, we have a topsoil level where the water goes down, then it hits the sand layer here and keeps going down, then it hits this. Nothing but clay. Won't penetrate, so it just sits on top, and that's our groundwater.
And this isn't going away, right? I mean, even if we get this water out of here, we've got more of the water table that's going to refill it.
Right, it's literally all coming down the hill. So we have to control this water. And we're going to do it by digging a trench, which I already did down the middle.
Yeah.
And in that, I'm going to put a pipe. Now, this pipe has holes in it, so that water's just going to go right inside the pipe. We'll lay it down in. Now we're going to take and cover it with some of this trap rock.
And so the idea is that this pipe is going to take all the water from this side of our hole
Right.
and bring it down to that side.
Right, and where I was down here is I was digging a hole for the pump we're going to put in temporarily to dry this out.
Okay.
So what I did is I dug a hole outbound of the wall.
All right, so the foundation is going to end here. You're saying that's outside.
Right. So we're going to just take and set the pump in there. It's about a foot deep. And what I want to do now is take some of these rocks, put them down on the bottom so that the pump won't suck up all mud.
All right.
Once we get a bunch of those in, we'll put some of the trap rock in and then we'll set the pump. Now, if you grab that bucket of stone, we're going to use the rocks and the stone in the bucket to keep the pump from getting all filled up with dirt.
So this is just a little base.
Yep.
Boy, right in the middle for me.
Alright, now we have a nice base for that pump. Okay. Alright, grab the pump.
Big pump.
Get it in there nice and level.
Yep.
Fire her up.
Oh yeah, that's flowing.
Look at it go.
Yeah. So now this is just a temporary solution to get this dry so you can pour the foundation. But once it's poured, this water's going to want to keep coming back.
Right, we're going to use that pipe to carry the water over to a permanent sump pump be located inside the foundation. Now the homeowners already have two in the basement, so this will be a third one, and hopefully this will help keep the basement even drier.
All right, well, I'll let you finish getting this dry. I'll go check on the chimney.
Let me know how they're making out.
Coming up next,
Chimney's in the way, so we're just gonna remove it, patch that wall, and move on.
We're going to get to it.
but first, here's a tip. R value is the resistance of heat transfer through insulation. The higher the R value, the greater the insulating power. Recommended R values change based on climate, and R value can be calculated by multiplying the depth of the insulation by the per inch value of that type of insulation. Build up layers of insulation until the desired value is reached based on the region in which you live. We'll be right back.
Hey, Mark, good to see you again.
Hey Kevin, how you doing?
I'm doing all right. So we saw you a few years back in East Boston. You did some masonry work for us there, and you're going to do some for us here.
That's right. What we have here is a little different. We have this chimney.
Mm-hmm.
Again, not original to the house. We think it was done sometime around the 1970s.
And so what tells you that? How can you tell the date?
Well, the style of bricklaying is different. Back when this house was built, the brick were actually much thinner. These bed joints right here are thinner. The head joints right here are thinner. Material is just a bit different, but this is a great indicator right here. This cook.
Yeah, this is sort of the giveaway, right? They
Right.
weren't using these back in the 1700s, were they?
Not at all, no.
So cooker goes, and I know we've got an addition coming in here. The two walls have got to meet. Is our chimney in the way or out of the way?
Chimney's in the way, so we're just going to take this hip as you see it, remove it, patch that wall, and move on.
So we got to get to it. See if we can beat the rain.
Let's get the tools right.
All right, give 'em.
We're going to try to go soft, just a hammer, chisel. Don't want to compromise any integrity on the chimney. And more importantly, again, trying to save these brick.
So Mark, this is your soft approach, huh?
That's right, yeah. A little tougher than I thought.
Yeah.
Usually if we can pop this top piece, everything will come easier.
So you're just trying to put a little seam here between concrete and brick with the chisel and break it free?
Exactly.
All right. Keep softening it.
Yeah.
So what are you finding, Mark?
What we're finding, Kevin, is the mortar is harder than the brick. So consequently, we're losing a lot of bricks as we're trying to save them.
Mortar stays, brick breaks. Does that
That's
mean
right.
you can't save them?
It does not look like that. So
Big, heavy sledgehammers, a lot of guys. Get this thing to the ground real quick.
So you're gonna go hard.
We're gonna go hard, yep.
Mark, that is a pretty big pile of debris from a little cooker, but I guess it means you got to salvage more brick than you anticipated.
Yeah, as we got into it, Kevin, things started to go our way for once, so we ended up with enough brick here to patch this area.
All right, so you got lucky with the brick, and we got lucky with the weather.
Yeah, building in New England.
Closed captioning provided by. When you see this symbol, you know you're watching something that's educational and informational. And when it's during one magnificent morning on the CW, you're seeing something that's surprising and intense, exciting and transformative, and exceptionally interesting. It's One Magnificent Morning, Saturdays on the CW.